So this is the sixth class on Cortex M4. So today I'm going to teach about 7-segment display. The 7-segment display, as we know that it is composed of several leads, and the lead has two terminals, anode and cathode. Anode is usually connect to the positive terminals and the cathode to the negative. So this is 7-segment display, and it composed of several leads. Lead 1, 2, 3, 4, 5, 6, 7 and 8. This dot is also a lead, okay? And a byte of data should be sufficient enough to drive all the segments, because a byte contains 8 bits, right? And this lead is also in total 8. So if all the bit is set, 8 bit is set, then it can turn on the lead. That's why turn on the 8 lead. So the 7 segments can have common anode or common cathodes. With common anode, the anode of the lead is driven to the positive supply voltage. The anode, as we know, that is always connected to the positive supply, and the cathode is connected to the negative terminals, as we know that. The common cathodes, the cathodes of the lead is grounded. In common cathodes, the cathodes of the lead is grounded, and the microcontroller is connected to the positive terminals of the lead. That is the anode. In these configurations, if the microcontroller doesn't have if the microcontroller is failed to supply sufficient power supply to the 7-segment leads, then it should use a buffer between the 7-segment leads and the microcontrollers, like this. Between the microcontroller and the 7-segment leads, it use a buffer. Buffer here is the transistor, or you can use IC chips. IC chips can be many. It composed of many things. Depends on how you design the IC. But for transistor, transistor amplify the currents. So if the microcontroller has for example small voltage supply, and the lead needs more voltage supply to turn on, then using a transistor circuit, you can amplify the currents, and with bigger currents you can turn on the lead very easily. That's why. That's all. And this one is the bit of the byte, and this one is the leads in the 7-segment is represented by A, B and C, D up to H in the diagram, right? Here that was A, B, C, D, E and T, H. So this one is segment patterns for the digit, 10 decimal digit. Let me check whether the recording shows. So this one is the digit, and if you want to display this digit, this one is 0 to 9, and this one is 0 to 9. And if you want to display on the 7-segment leads, you have to give these values. And how these values you obtain is, for writing 0, you have to turn off the lead D7 and D6, that is lead G and H. Turn off this G and H lead, then you can get zeros. That is, you turn off the lead G and H, then you can get zeros, because A, B and C, D, E, F will be turned on, then it will form 0, right? And for because of that, there is you are having this G and H, it should be H, we can represent by dot also, because that represents dot, right? Because of that. So this one is 1 hexadecimal, the 4 combined. So this one is 3, and this one is 4 combined 1 hexadecimal, and this one is F, so it becomes 3F here. Why this one is 3F? This one is 3, right? 3, 1 is 3, and this one is F, right? 1 means F, that's why 3F. And if you want to again display 1 on the 7 segment display, then you have to turn on the lead D2 and D1 only. D2 and D1 means lead number B and C. If you turn on, then you get 1. The rest will be off. Okay. So this one is on only, then it becomes 6, right? 1 1 0 is 6, and this one is 0. That's why it becomes 0x06. And 2 3 4 5 6 7 up to 9 you can play, and you will get all this value. And port B as an output port to drive this segment. Port B is an output port. Because this is output section of the microcontroller. This one is input section of the microcontroller. So port B is an output port, okay, to drive this segment, 7 segment. And port A, okay, and port A as output to select the digit. And port A is output to select the digit. This port A is to here select the digit in zeros place or in ones place. So in below okay figure, the same segment for port digit 1 and 2 are connected to the same I/O port pins, because this digit in the zeros plus, this digit in the ones plus is connected to the same I/O pins, right? Same pin, okay. The common cathode of each pin must be driven separately so that only one digit is on at a time. Must be driven separately. In the common cathode, this is common cathode diagram, right? In the common cathode, what we do is, in the common cathode, the cathode area is grounded, right? So this one is common cathode figure of 7 segment representation. So in this, each of this digit should be driven separately. That means this one is on, then this one is off, this one is on, then this one is off. So the 2 digits are turned on alternative. So in this figure, okay, this is microcontroller, this is 7 segment display, this one is another segment display, this one is the circuit connection. All those you can use wire, okay. And this one is what? This one is the buffer driver. You can use either transistor or IC chips. IC chips you can design in several ways according to the diagram you prefer. IC circuit diagram you prefer. And why it says current driver, okay, because it can be because usually this one is IC chips or transistor, and transistor amplify the currents. That means the currents become more stronger. So if currents become more stronger, the currents that supplied by this microcontroller is more stronger here, then it can turn on the lid very easily, right? That's why. Here we are choosing all the pins of this port B. Here we are choosing only pin number 6 and 7 of port A. But here in real life, there will be so many pins. You can use other pin also, but I'm choosing only pin number 6 and 7 here. And so we will write a very small simple code on how to display the digits on this 7 display. Okay, I'm including the library of this microcontroller TM4C123J6PMs, the debug microcontroller. And this one is the delay function that used to give some delay or make it delay means making it wait for some time. This one is the main function. I'm taking one array of char type. Char type can include all those digit and integers, alphabet. Okay, and unsigned usually refers to positive values. I'm taking some value. Okay, this one is okay, right. This X will be small letter. I'm taking these values. What are these values? This values is this values again. These are the values. 3 from here to here again. Because I want to display this is a 0 up to 9 on the 7 segment display, and I'm putting all of this in an array. Okay, system control RCGC GPIO Cortex. System control 1 it's choosing this register, 32-bit register RCGC GPIO, which and the function of this GPIO is to select a particular ports, whatever ports you want, and I'm selecting port A here because 0 is in hexadecimal this and 1 in hexadecimal is this, and this one is port A, port B, port C, port D, port E, port F. So I'm choosing port A or GPIO. Okay, GPIO port A is same. Okay, but this X will be small. Okay, here I'm again choosing another ports what this function, this resistor, 32-bit resistor, what is the function of this resistor is to choose a particular port, right? So I'm choosing here, okay, port B, because 0 represents in hexadecimal this, and port B and 2 represents 2 in hexadecimal as this. So this one is port A, port B, port C, port D, port E, port F. I said only port B, that's why I choose only port B, or GPIO-B. And why I'm choosing again this two port A and port B, because in the figure I have to set up the hardware. Okay, this is hardware, so I have to set up, that's why I choose port B and port A. Okay, and after this I choose already port A and port B, and after this I have to select pin of that particular port, right? That's why GPIO-B. And here I'm choosing, okay, DIR. What is the function? DIR is a 32-bit registers, and what this DIR says is choose the pin of the particular port as an output. So output or input, but here I'm choosing as output. Okay, if it is written like this, then I'm choosing it as, okay, what input. Okay, I'm clearing the values for the input. So this one is I'm choosing it as output. So I'm choosing, okay, which pin. Here I'm giving FF because F in hexadecimal is this, and F in hexadecimal. I'm choosing, okay, whole, okay, the pin 0 to 7 I'm choosing as output port, because here I'm choosing the whole pin 0 to pin 7 of port B as an output port, right? Because of that. And after choosing, okay, that, I'm selecting yeah, then I have to, okay, then I'm setting, okay, this pin that whatever I choose as digitals, because everything works in digital, as I'm not by default, as I'm not choosing any analog operation. I'm not doing any analog operation here, so I'm setting it as digital. Means setting means giving 1 to the pin I have chosen. Which pin I have chosen, okay, all of this, right? Then I have to set, okay, all of this. Set means supplying 1, that means it becomes FF. So the value, okay, FF is coming here. Here also the value FF is coming here. And so like this, okay, for port A, okay, C is C is 1100, because I'm choosing only this one is 0, 1, 2, 3, 4, 5, 6, 7. This one is pin 6, this one is pin 7. I'm choosing only pin 6 and 7 of the port A, because 6 and 7, right? Because I'm choosing only here pin 6 and 7, right? I have to set up the hardware. So here in the diagram, which hardware pin I'm choosing only pin number 6 and 7. So I have to choose only pin number 6 and 7. So that's why I choose only pin number 6 and 7 of port A. I set. and whose pin I have chosen, I have to set it as digitals, because by default it is set, by default it will be digital, as I'm not using analog function here, so it has to be not by default, but not by default, but it has to be in digital, because everything works in digital. So and also I'm not using any analog operation here, because of that. Because why I need to set to digital, because it can be analog also, right? Because of that. And these are the setup. So what setup I have done, I have connect this segment to this pin, this segment also to this pin. I have connect this segment to this particular pin. I have connect this to this particular pin. So this is only required, right? Okay, then the setup is finished, so let's do follow. Here what we are doing is in the GPIO B, in the port B, GPIO B means port B, we are supplying data, but in the port B, which pin we have chosen? We have chosen for this port B, we have chosen all the pins 0 to 7, right? So in the pin 0 to 7 of the port B, we are supplying a data. And what is the data? This one is a 32-bit register that says to supply a data, to supply data to the pin of the particular ports. This is a 32-bit register that says supply data to the pin of the particular port you have chosen. So what data we are supplying is from the array array 1. This one is 0, this one is 1. So we are supplying the values 0x 06. 0x06 means this one is 0 in hexadecimal and this one is 11. So in the bit 0 to 7 of this, in the pin 0 to 7 of this port B, we are supplying this value, right? We are supplying this value. So we are going to supply these values. That means why we are supplying these values, because we want to display the digit 1. The digit 1 is not coming from this. This one is just array index number. This array index number is 0 1 2 3 like that. So we are just supplying this value 0x 06 0x06. We are supplying these values because 0x06 we are supplying these values because we want to display 1 on the 7 segment. Right. And then after this GPIOA supplying data equal to 0x and 0. 0x and 0 means right. So in the pin of this GPIOA port A, in the pin of the port A, we are supplying these values. What data says, data is a 32-bit register. This says to supply value, right? Data. So what data we are supplying the values is this one. So I set only pin number 7 on. Pin number 7 is on. Okay. This one is pin number 7. Pin number 7 is on means this one. Okay. I'm choosing this ones plus digit. So it is connected to port B, all the digit, and then it is connected to the 7 pin. That means this one is connected to port B, this one is connected to 7 pin, this one, that means the digit in ones plus. So we have write the code for this. Now we will write the code for this. Make it delay, give some delay so that it slows down a little, so that it blink for some time, that we can see with our own eyes. Otherwise, if it blink very display it very fast, then we cannot see, right? Here we will display index number 4. Digit in index number 4. Okay, digit in index number 4 is this one is 0, 1, 2, 3, 4. 0x. We are supplying this again. So 0x66 means 0, 1, 1, 0. 0, 1, 1, 0. So in this pin, so in this pin of port B, for port B we select all the digit, all the pin, right? 0 to 7. Yeah, we select all the pin, right? 0 to 7. In this particular pin 0 to 7, we are supplying these values. Okay. Then here we are supplying in this port B, we are supplying that value. Then GPIO data 0x4 4 means and 0 means in hexadecimal. Okay, here for this particular pin port A, this pin we have chosen pin number 6 and 7. In this particular pin we are giving a data. Okay, in this particular pin 6 and 7 of port A, we are giving a data. Okay, and the data value is 0x40, and so it is this value, right? But we are giving 1 only to the 6 pin and 0 to the 7 pin, so I choose only 6 pin. Okay, that means I want to display this value, whatever digit that is going to be displayed by this value. Okay, it will surely, as you know, it will display the digit 4. Whatever value digit is going to be displayed by this value, I am for that I'm selecting pin number 7. Okay, sorry, pin number 6. That means pin number 6 means this one, right? So the digit 4 will display here. So I have done configuration for this because this section I have connected to pin number PA6 only, and I have also given values on port B. I have given values on port B right here, and I'm choosing only pin number 6 here. So give some delay. So what are the things I have done? I have set for this digit, by choosing this pin for this and giving value from here, port B for this, for this also I have given value from this, and choosing this pin on. So configuration is finished, right? So in this way it will display, and we'll write some delay call. I'm taking two variables. This one is outer for loop. This one is inner for loop. So why this function as a whole will make it wait for 1 millisecond, and because of that this number 3180 is used. 3180 is used because so that the whole functions give 1 millisecond as a whole. After calculation of it, this 3180 is written here, and the value of n is depends on how many the value of n is, you have written 8 here, so it will pass to this n, and as the function give 1 millisecond delay, and when you call these functions as you are giving 8, so in details it will be 8 millisecond. So because you are writing passing 8 here, and then 8 into whole will be 8 millisecond. As a function, this one will run once, and this one will run 3180 times, this one will run once, this one will run 3180 times, until this n becomes 8. That means in details it will be 8 into 3180. That much millisecond, and as you know it will make 8 milliseconds. This is not so important. I'm having a writing in capital this X. So kindly don't mind if I write in other program. Please know that this X will be small. And what this function says is the system has this register. It is a 32-bit register. Every register is 32-bit register. This register has given a values this, and F in hexadecimal is written this, and this 2-bit is given 1 to set coprocessor C11, and this one is to set coprocessor C10, and it is required so that ARM coprocessor use the floating point units of the system, because sometimes you use float doubles values, because in this delay calculation even you are using very small units, right? Because of that. So this all for this session. I think I'm taking a long time, little longer time, but in when it comes to I2C or SPI, it's going to be the programs are very long, so it will take much more time and please don't mind for that. Okay. Okay, thank you all for this session.